Good day, everyone. I am Arvin J. Emilio from BSED Math 3B. For today, I will be presenting my final investigation in M114. So, let's get started. So, this is called the honeycomb pattern. So, in Pascal's triangle, the flower petal or hexagon pattern is very known. It states or shows that if you pick a number not on its boundary and look at the hexagon of numbers surrounding it, it will produce two groups of alternating numbers that has the same product. So let us look in this illustration. So in Pascal's triangle, we have picked the number 15. So there are two groups of alternating numbers surrounding it. First group we have 5, 20, and 21. Second we have 6, 10, and 35. So if we multiply 5, 20, and 21, the product is 2,100. And if you multiply 6, 10, and 35, the product is 2,100 also. So they have the same product. But now, I have discovered another pattern using these hexagonal numbers. This is the honeycomb pattern. So in this pattern, we are going to show and prove that the sum of all the numbers inside the hexagon when divided by 2 is equal to the middle number below that hexagon. So let's proceed. So step 1, of course, we need to understand the problem. So the sum of all the numbers inside the hexagon must be an even number. So we could always divide it by 2. So we will have 4 cases. First, 6 odd, 1 even. Second, 2 odd, 5 even. Third, 4 odd, 3 even. And last, we have 7 even numbers. 7 odd numbers is not applicable since it has an odd result for sum and it cannot be divided by 2. So step 2, we need to devise blank. Of course, we will use the method look for a pattern and applying some mathematical operations. So now let's proceed to step number 3, carry out the plan. So given this Pascal's triangle, the first hexagon is located from row number 2 to row number 4. And as we can see, we have 1, 2, 3, 4, 5, 6 odd numbers and 1 even number. So adding all of the numbers inside the hexagon, we will have 1 plus 1 plus 1 plus 1 plus 2 plus 3 plus 3 is equal to 12. And 12 divided by 2 is equal to 6. So we can see here 6 is the middle number below the hexagon. Therefore, we satisfy all the conditions. So another illustration. The second and third hexagon is found in row 3 to row 5. So they have the same numbers inside. We have 1, 2, 3, 4 odd numbers and 1, 2, 3 even numbers. So adding all of the numbers inside the hexagon, we will have 1 plus 1 plus 2 plus 3 plus 3 plus 4 plus 6, that is equal to 20. And 20 divided by 2 is 10. So we can see here 10 is the middle number below the 2 hexagon. Hence, we satisfy all the conditions. Another illustration. The fourth and fifth hexagon is found or located from row 4 to row 6. So also, they have the same numbers inside. We have 1, 2, 3, 4 odd numbers, and 1, 2, 3 even numbers, just like the previous one. So adding all of the numbers inside the hexagon, we will have 1 plus 1 plus 3 plus 4 plus 5 plus 6 plus 10 is equal to 30. And 30 divided by 2 is 15. 15 is the middle number below the two hexagons. Therefore, we satisfy all the conditions. Another one, the sixth hexagon is found also from row 4 to row 6. And we have 1, 2 odd numbers, and 1, 2, 3, 4, 5 even numbers. So adding the numbers inside the hexagon, we will have 3 plus 3 plus 4 plus 4 plus 6 plus 10 plus 10, that is equal to 40. And 40 divided by 2 is 20. The middle number below the hexagon is 20. Therefore, we satisfy all the conditions. So for our last illustration, the seventh hexagon is found from row 5 to row 7. So we have 1, 2, 3, 4 odd numbers, and 1, 2, 3 even numbers. So adding all of the numbers inside the hexagon, we will have 1 plus 1 plus 4 plus 5 plus 6 plus 10 plus 15, that is equal to 42. And 42 divided by 2 is 21. And once again, 21 is the middle number below the hexagon. Therefore, we satisfy all of the conditions once again. So as we apply all of the conditions to the succeeding rows, we will always observe the pattern or the honeycomb pattern right. So for our step 4, look back. So using observation and investigation, we have come up with another pattern that can be seen in Pascal's triangle. This triangle is really a thing of beauty, that it is composed of numbers with different patterns in it. In this investigation, we have also used some operations like addition and division to come up with another pattern. So that ends my presentation. Thank you for watching, and God bless us all.